Okay, here we are with Lesson 7, Understanding Equations. And some vocabulary that we're going to be using throughout this lesson and should be in your journal are the following. First of all, a variable, remembering that a variable is a symbol such as a letter that represents a number, and it usually is the placeholder for a number until we figure out what that solution is. An equation is a statement of equality between two expressions. And a number sentence is a statement of equality between two numerical expressions. That means there are no variables in those expressions. And a solution to an equation with one variable is a number that, when substituted for the variable in both expressions, makes the equation a true number sentence. All right, so for our opening exercise, go ahead and read it in preparation for the discussion. The goal of this lesson is to learn how to build expressions and then write equations from those expressions. So first, using the fact that the distance between the wall and the poster is 2 feet, write an expression in terms of the distances between the width of the posters for the total length of the wall. So we could write 2 plus 4 plus 2 plus 4 plus 2. Or we can write this as 3 times 2 plus 4 plus 4. Or you could have 3 times 2 plus 2 times 4. Or you could have 3 times 2 plus 8 if you want to have it that way also. So any of these numerical expressions is correct. So they are based on already knowing the answer. But suppose we want to solve the problem using algebra and did not know the answer was 2 feet. So we're going to let the distance between a picture and the nearest edge of the wall be X amount of feet. We're going to write an expression for the total length of the wall in terms of X. Well, we can either write it as X plus 4 plus X plus 4 plus X, or because we know we have 3 X's, we can write it as 3X plus 4 plus 4, or we can write it as 3x plus 8. So setting this expression equal to the total length of the wall described in the problem, which is 14 feet, will give us an equation. So that equation could be either x plus 4 plus x plus 4 plus x equals 14, or simplifying that, we could get 3x plus 4 plus 4 is 14, or last, we can have 3x plus 8 is equal to 14. So using the answer from the opening exercise, check to see if your answer makes the equation true or false. Is the calculated distance consistent with the diagram that is drawn? Well, we had 2 as our answer in the opening exercise, so our equation is true. We say that 2 is a solution to the equation in 3x plus 8 equals 14 because when it is substituted into the equation for x, it makes the equation a true number sentence. So here is our vocabulary, number sentence. This number sentence is equal to this number sentence. So 3 times 2 plus 8 is 14, and 14 is equal to 14. So read and try the next parts of the question, that is about your parents redecorating the dining room. Finish all parts based on the first problem, remembering that 12 inches is equal to 1 foot. When you are done with this, continue the video. All right, so let's see how far you got. There's 2 ways to approach this problem. First of all, you can leave it in feet or convert it to feet, in which case 25 inches for each poster or picture would be 2 1/12 feet. Then using the fact that the total length is 10 2/3 feet, subtract 2 1/12 2 times, and then what is left over is split into 3 equal parts, so that would be divided by 3, and you should end up with 2 1/6 feet. The other way you could do this is to convert our feet to inches. So knowing that the total length of the wall is 10 2/3 feet, multiplying 10 by 12 and 2/3 by 12 is going to give us 120 plus 8 inches, or 128 inches. taking 128 minus 25 minus 25, and then again dividing it by 3 because we want 3 equal spaces, would give us 26 inches. So let the distance between a light and the nearest edge of the wall be x feet. So taking our first step and keeping it in feet, how could we express this equation in x feet? Well, again, it would be 3 times x plus 2 and 1/12, because remember that's representing the 25 inches, plus 2 and a 12th. Well, that whole number sentence then would be 3x plus 2 and a 12th plus 2 and a 12th would equal 10 and 2/3 feet. So now let's change this and let's call it y, but y is going to stand for inches. So what would that look like? Well, then that means we have to convert 2 and 1/12 feet, which is 25 inches, or actually we can use that. But now we have to convert 10 and 2/3 feet to 128 inches. So therefore our equation would be 3y plus 25 plus 25, or 3y plus 50, equals 128. So now what values of y would make this second equation true? 24, 25, or 26? So showing our work, substituting y for 24, we would get 72 plus 50 equals 128. Well, 122 being equal to 128 is a false statement. If we substitute 25 in the same manner, we would get 125 equal to 128, which is a false statement. But if we use 26, we get 78 plus 50, which is 128. And 128 is equal to 128 is a true statement. So since substituting 26 for y results in a true equation, the distance between the light and the nearest edge of the wall should be 26 inches. So how did the change in the dimensions on the second problem change how you approach the problem? Well, the fractional width of 10 and 2/3 feet make the arithmetic way more difficult, and the widths of the posters are expressed in different units than the width of the room. So this also makes the problem more difficult. So since this problem is more difficult than the first, what additional steps are required to solve the problem? Well, the widths must be in the same units, therefore you must either convert 10 and 2/3 feet to inches or convert the 25 inches to feet. So describe the process of converting the units. Well, to convert 25 inches to feet, we have to divide the 25 inches by 12 and then write the quotient as a mixed number. Or to convert 10 and 2/3 feet to inches, we have to multiply the whole number 10 by 12 and then multiply the fractional part 2/3 by 12 and then add those two parts together and get the total number of inches. So after looking at both of the arithmetic solutions, which one seems the most efficient and why? Well, converting the width of the room from feet to inches made the overall problem shorter and easier because after converting the width, all of the dimensions ended up being whole numbers and not fractions. So does it matter which equation you use when determining which given values make the equation true? Explain how you know. Well, yes, since the values were given in inches, then the equation 3y plus 25 plus 25 equals 128 can be used because each term of the equation is in the same unit as the measure. Well, if one uses the other equation, what must be done to obtain the solution? Well, if you use the other equation that dealt with feet, you would have to change the given values of 24, 25, and 26 inches into their respective feet, which would be 2 feet, 2 and a 12th feet, and 2 and 1/6 feet. All right, so let's take a look at the example. The ages of 3 sisters are consecutive integers. The sum of their ages is 45. So calculate their ages, and in part A, we're going to use a tape diagram to find their ages. So if we consider the youngest sister as X, some age, Well, then the next sister would be x plus 1 because it is consecutive, so it'd be the next number. And the oldest sister would be the age of the younger sister plus 2 because it would be 1 more than the second sister and 2 more than the youngest sister. And altogether, all three of these would equal 45. So if we know that it's 45, we can subtract 3, which gives us 42. And then because we have 3 equal numbers, divide it by 3, and that would be 14. So the youngest sister would be 14. The second sister would be 1 year older at 15. And the oldest sister would be 1 year older than the second, or 2 years older than the youngest, and that would be 16. So for part B, if the youngest sister was x years old, describe the ages of the other two sisters in terms of x. Write an expression for the sum of their ages in terms of x, and use that expression to write an equation that can be used to find their ages. So if the youngest sister is x years old, then that means the second sister would be x plus 1. And the third sister would be x plus 2. So if you sum their ages, it would be x plus 1 plus x plus 2. And the equation would then be x plus 1 plus x plus 2 equals 45. So for part C, it says determine if your answer from part A is a solution to the equation you wrote in part B. Well, if you plug in 14, then it would be 14 plus 14 plus 1 plus 14 plus 2. When you simplify this, you get 45, and that is a true statement. So let x be an integer, write an algebraic expression that represents 1 more than the integer. Well, that would be x plus 1. Write an algebraic expression that represents 2 more than that integer, and that would be x plus 2. So the unknown unit in the tape diagram represents the unknown integer, represented by x. Consecutive integers begin with the unknown unit, and then every consecutive integer, therefore, increases by 1 after each one. So take a look at the exercise and check your answers as you need to. All right, so you've gotten started. Let's see where you're at. So if Sophia pays $19.99 membership fees for an online music store, she also buys 2 songs from an album at a price of 99 cents each, what is her total cost? Well, if you did 2 times 99 plus $19.99, you should have $21.97. So if she purchased some amount of songs, which we'll call N, for 99 cents each, write an expression for the total cost. Well, then that would be 99 cents times each song, which is N, plus the membership fee, which is $19.99. Well, Sophia's friend has saved about $118 but is not sure how many songs she can afford if she buys a membership and some songs. So using the expression in part B, write an equation that can be used to determine how many songs she can buy. Well, again, that would be 99 cents times each song plus a membership fee of $19.99, and she has $118 total. So it would be equal to, but not more than, $118. So using your equation, can she buy 101, 100, or 99 songs? So again, by substituting in and simplifying, we know that for 99 songs it is true. For 100 songs it is not true because they are not the same. And for 101 songs, it is not true, so this is also false. All right, to wrap this up, describe the process you used today to create an equation. What did you build first, and what did you set it equal to? Also, describe how to determine if a number is a solution to an equation. And to summarize, in many word problems, an equation is often formed by setting an expression equal to a number. To build the expression, it is helpful to consider a few numerical calculations with just numbers first. For example, if a pound of apples cost $2, then 3 pounds would cost 6 because it's 2 times 3. 4 pounds would cost 8 because it would be 2 times 4. And n pounds would cost 2 times n dollars. If we had $15 to spend on apples and wanted to know how many pounds we could buy, we could use the expression 2 times n to write the equation 2n equals 15, which would lead us to find an answer of 7.5 pounds. To determine if a number is a solution to an equation, substitute the number into the equation for the variable or letter and check to see if the resulting number sentence is true. If it is true, then the number is a solution to the equation. For example, 7.5 is a solution to 2 times n equals 15 because 2 times 7.5 is 15. All right, we'll see you in class.